Hello, in this video we continue study on the chain rule and we consider some problems, how to simplify derivatives. As I mentioned several times, if they just ask you to find the derivative, so you don't have to simplify, right? But sometimes you need to solve this equation, y prime equal to 0. You may look at this equation like phi x such that the tangent line is horizontal, right? And we discussed one time about that, because when the derivative is 0 means the slope is 0. When the slope is 0 means the tangent line is horizontal. That is very important. In the next chapter, when we study application of the derivative, we need to solve this equation again, right? But for critical points. We'll talk about this in detail later. But sometimes, and not only sometimes, most of the times, we need to solve this equation. So when you have a derivative, you need to simplify that. Agree? And I think one of the most difficult, and not about difficult, but confusing, right? Confusing topic is how to simplify functions with radical functions. Okay, let's consider the following example, and we'll see. Suppose that you have function y equal to x squared square root of 1 minus x squared. Let's find the derivative of this one. Okay, that is x squared derivative times 1 minus x squared, and then plus x squared times derivative of 1 minus x squared square root. Okay, so for this term we have 2x times square root of 1 minus x squared, which is not difficult. Let's find the derivative of 1 minus x squared square root separately, and then we just put the derivative into the formula. Okay, let's find 1 minus x squared derivative. So usually when I have radical function, I will rewrite that in the power form. I have 1 minus x squared to 1/2, right? And then derivative. Now we need to use the chain rule, right? I have two functions in here. The first function, the inside function is 1 minus x squared, and the outside function is power 1/2. So if we apply the chain rule, I have 1/2, 1 minus x squared, 1/2 minus 1, which is derivative of u 1/2, right? And then times u prime, which is 1 minus x squared derivative. Then I have 1/2, 1 minus x squared to 1/2, right? Negative 1/2 times negative 2x. Then you might simplify 2 with 1/2 in here, and the power negative 1/2 will be converted to 1 over 1 minus x squared to 1/2, right? In here I have negative x, so I can write that is negative x over square root of 1 minus x squared. We use this several times, right? You convert from radical to power function. Okay, so we have derivative of square root of 1 minus x squared. Now we plug this into this formula. We have negative x over square root of 1 minus x squared. Okay, again, if they don't ask you to do anything, just ask you to find the derivative, you can leave your answer like this. I accept this answer. But as I mentioned several times, sometimes you need to solve this equation. So in order to solve this equation, you need to simplify your derivative, right? Okay, let's do this. Since I see x in here and x in here, right? I can factor that out. If I have negative in here, So I compare with positive, I will get negative. Okay, so I have the following one, that is x. Inside I have 2 square root of 1 minus x squared minus x squared over square root of 1 minus x squared. Okay, in my experience, some students might have trouble with this. This is of the form 2a minus b over a, where a is 1 minus x squared square root. Okay, so you just cross multiply, right? You just cross multiply and make a common denominator, which is a. So you have 2a squared minus b. You see that? If you apply this for your function, you would get x. In here, a is 1 minus x squared square root, and here I have 2 times square root of 1 minus x squared, and then square. You see? Minus x squared. But square root and square, they will be cancelled out, right? So I have 2 times 2, 1 minus x squared minus x squared divided by square root of 1 minus x squared. Then you open parentheses, you have x, 2 minus 2x squared minus x squared divided by square root of 1 minus x squared. Then you have x, 2 minus 3x squared over square root of 1 minus x squared. Now, the derivative looks really nice, right? That is y prime. And of course, if they ask you to solve the equation y prime equal to 0, it is easy. Okay? You see, it is long. It's long enough, right? But no, that's how we can work with radical functions. Because especially for such, like square root, cube root, or nth root, because when you differentiate that, you have some part, right, in the denominator, and you need to you need to use cross multiplication to simplify your derivative. Okay, let's do one more example. You have f of x equal to x over cube root. Okay, now we'll work with cube root x squared plus 4. So let's find the derivative of this function. We may use the quotient rule, agree? But I like the product rule because it seems to be easier for me, okay? So in such situation, especially in this situation, we have radical function and we know how to convert radical function to power. And if you have a power function in here, you might convert, just flip that, right? And we get some product. Look at this. I have x divided by x squared plus 4 to 1/3, right? And that is nothing but, x times x squared plus 4 to negative 1/3. You see, you already have product. And now you can use the product rule to find the derivative. How about that? All right. So from here, I can find f prime equal to, the derivative of x is 1, so I don't write it. I write x squared plus 4 to negative 1/3, right? Plus x. Now I use the chain rule for this function. I will not do in detail like previous example. If you want, please check that, okay? So I use the chain rule right here. First, I use the chain rule for the power function, right? I have negative 1/3, you see? And then x squared plus 4 to negative 1/3 minus 1. That is the derivative of the outside function, which is the power function in here. And then times the derivative of the inside, x squared plus 4 derivative. Okay. Now I have x squared plus 4 to negative 1/3. Let's keep that. Minus x over 3. Okay, the derivative of x squared plus 4 is 2x. So I would like to bring 2x together with the x. Okay, so I have right here 2x. How about that? And here I have x squared plus 4 to negative 4/3. Okay, now how to simplify this? How to make this more beautiful? You might convert back to the radical function, right? But for such function, there is very nice approach. Look at this. Now I will factor x squared plus 4 to negative 4/3 out. So if I take this out, right? X squared plus 4 to negative 4/3 out. So what do you have from here? You have x squared plus 4 to what? To negative 1/3 minus negative 4/3. Is that correct? Because you factor that out, right? Since you bring that out, you need to subtract that. Is that correct? So 1/3 is the original one. You have to subtract negative 4/3. Then minus 2x squared over 3. You see? And you have x squared plus 4 negative 4/3. In here you have x squared plus 4 because the power is 1 minus 2x squared over 3. You see? So basically, that is what? That is x squared plus 4 to negative 4/3. And here you have 3x squared plus 12 minus 2x squared over 3. So I can write that is, you simplify 3x squared with 2x squared, right? So you have 1x squared plus 12 divided by 3, x squared plus 4 to 4/3. Now I can convert this, right? We have negative, so we just convert to the denominator. Done. You see? A very nice derivative. So in this problem, right, we choose this factor. You see, x squared plus 4 to negative 4/3. We don't choose this one. We choose the smaller one. Is that correct? Because if we choose negative 1/3, so in this term you still have something like negative 1. Does that make sense? You see, if you bring x squared plus 4 to negative 1/3 out, right? Then from this term you would have x squared plus 4 to negative 4/3 minus negative 1/3. Is that correct? Because you take that out, so you have to subtract that. Then this is negative 1. You still have power negative 1. That is not good. So that's why we choose to bring this term out. You see that? And in the previous example, we work with square root, right? We work with square root. Actually, you might do almost the same thing. You might choose the approach we just finished. Agree? But in that case, you might choose 1 minus square root 1 minus x squared to negative 1/2, which is this term. I hope you might try that. Okay, please try that to see how that works, and you feel actually that is not that difficult. Okay, now let's move to another function, which is another guide of simplification. So suppose that you have function y equal to 3x minus 1 over x squared plus 3 squared and you need to find y prime. All right. Again, you need to use the chain rule, right? Because you have function u squared where u is 3x minus 1 over x squared plus 3. So you know, if you apply the chain rule, you have 2u, that means 2 3x minus 1 over x squared plus 3 times u prime. So I write here 3x minus 1 over x squared plus 3 prime. Right? And you use the quotient rule for u prime. You can use the quotient rule for u prime. I don't do anything with this term, right? X squared plus 3. By the quotient rule, I have x squared plus 3 squared in here, right? So the derivative of 3x minus 1 times x squared plus 3 minus 3x minus 1 times x squared plus 3 derivative. That is the quotient rule. You know, multiplication in here means, you know, you multiply with all things in here, okay? So I have 3x minus 1 in here, x squared plus 3, and then I calculate the derivatives in here. I have 3 times x squared plus 3 minus 3x minus 1 times 2x divided by x squared plus 3 squared. And now our job is to foil this out, right? And then we simplify. So I have 3x minus 1 divided by x squared plus 3. In here I have x squared plus 3 squared. We will combine them all together later. I have 3x squared plus 9 minus 6x squared and then plus 2x. I have plus because I have negative in here, you see, and negative. So when you multiply 2x with the negative 1, you get negative 2x. With the negative will be positive. Okay, now I think we are ready to compile everything. I have x squared plus 3 cubed, right? Because you have 1 and square in here. And 2 times 3x minus 1. 3x squared minus 6x squared, that will be negative 3x squared plus 2x and then plus 9. So that is what we have. Okay, let's try to solve at least one time, right? Y prime equal to 0. Y prime equal to 0. So if you need to solve this equation, you just put the top equal to 0, right? 2 3x minus 1 times negative 3x squared plus 2x plus 9 equal to 0. From here, you have 3x minus 1 equal to 0 or negative 3x squared plus 2x plus 9 equal to 0. So we need to solve these two equations. From this equation, I get 3x equal to 1 or x equal to 1/3. One solution. And this is quadratic equation, right? So I need to apply the quadratic formula. What is that? That is x12 equal to negative b plus minus square root of b squared minus 4ac over 2a. Okay, so according to this formula, I have x12 equal to negative b is negative 2 plus minus square root of 2 square minus 4 times a is negative 3 and b is 9 divided by 2 times negative 3. You see? And you simplify this, you get negative 2 plus or minus. Let me calculate this. So I have 4 minus plus 12 with the 9. 12 with the 9 will be 8, 108 plus 2 is 112, right? So square root of 112 over negative 6. Okay, or if you want, you can write that is 2 plus minus square root of 112 divided by 6. We might simplify more, but that's okay. So, if you need to solve the equation y prime equal to 0, so you can find 3 solution in here. Okay? I would like to challenge you, to solve this equation and where I think we still have one more example. This equation and yes, for this function. So and this equation. Okay, let's try to solve that. Agree? So now let's solve some problems involving trig functions, and then we solve one tangent line problem, and I think that is good for today. So you have 6 trig functions: sine of u, cosine of u, tangent of u, cotangent of u, sequence of u, and cosequence of u, right? Where u is a function. So if you want to differentiate these functions, you use the chain rule, right? For example, derivative of sine of u is cosine u times u prime. That's it. You see, derivative of cosine is negative sine of u times u prime, and this is tangent square u plus 1 times u prime, or sometimes you can write u prime divided by cosine square of u, right? We know that for tangent and cotangent we have 2 forms. So you have negative cotangent square of u plus 1 times u prime, or negative u prime over sine square of u. And sequence, you have sequence u times tangent u times u prime, and cosequence is negative cosequence u times cotangent u times u prime. That's it. Again, that is just the chain rule, right? Let's consider the following example. So you have y equal to square root of cosine of x. The derivative of this function is, cosine of 1 over 2 prime. Each time when we see a radical function, please convert that, into a power function, okay? And then this is what? This is u to 1/2, right? Derivative. So by the chain rule, I have 1/2 u 1/2 minus 1, and then times u prime. That is 1/2 cosine of x to negative 1/2 times negative sine of x, because the derivative of cosine is negative sine, right? So I have negative sine x. In here I write 2 times cosine of x to 1/2, or that is negative sine x over 2 square root of cosine of x. You see? If you have power function, y equal to cosine cube, for example, you want to find the derivative. Now you also use the chain rule, right? This is of the form u cube. So you have 3 u squared times u prime. You see that? And that is 3 cosine squared times negative sine of x. Right? So what happens if you have y equal to cosine of square root of 1 plus x squared? In this situation, the u is square root of 1 plus x squared. Actually in this case, you have 3 functions. You have 3 functions in here, okay? The first function, the very outside function, is cosine. The second one is square root. And then the last one is 1 plus x squared. All right? So for 3 functions, you may use the chain rule, right? Let me write it down for you. You have f, g, and h, x. And you want to differentiate this. So you differentiate the outside function and evaluate it at the inside, everything in here, right? Times, you move to the g, you have derivative of g, evaluate it at hx, and then derivative of hx. You see that? So from this, I can find the derivative of y. That is, you see, look at this. Derivative of cosine is negative side. So I write negative side. And I copy everything, right? 1 plus x squared. I finish with this. And then I move to the second function, square root of 1 plus x squared. But square root is power 1/2, right? So I write 1/2 in here. 1 plus x squared to 1/2 minus 1. You know, the derivative of the power function. That is the power rule, right? And then the last term is the derivative of 1 plus x squared, which is 2x. You see? You know, if we understand the chain rule very well, so you can write the answer right away. Okay? Now let's consider a tangent line problem, and then we finish today lecture. We have function f of x equal to 2 sine x plus cosine of 2x. Okay, let's find the tangent line to the graph of this function. At x equal to pi. Okay, let's pick pi. If they don't give you the y coordinate, it's okay. You can plug pi into the function, right? So I can write, y of pi is 2 sine pi plus cosine of 2 pi, and sine of pi is 0. Cosine of 2 pi is 1. So the function value is 1. Good. Now we need to find the slope. So we have to differentiate, right, the function. The derivative is 2 cosine plus. So for cosine of 2x, I need to use the chain rule. I have negative sine of 2x. How about that? Because the derivative of cosine is negative sine, right? And I keep 2x in here times the derivative of the inside, which is 2. Because 2 is the derivative of 2x. Then even we don't need to simplify because they don't ask us. From here, I can find the slope. The slope is equal to the derivative at pi. I plug pi into this function, 2 cosine of pi plus negative sine of 2 pi times 2. Sine of 2 pi is 0. So this term is 0. Cosine of pi is negative 1, right? So that's why we have negative 2. Okay. Once you have the slope, you have the point x and y. You can write the equation. Y minus 1 equal to negative 2x minus pi. Then y equal to negative 2x plus 2 pi and plus 1. And that is the equation of the tangent line at x equal to pi. Okay, so I think we finished the chain ruling here. If you have any questions, please let me know. Thank you.